Well, hey there, everybody. It's your boy, Mr. Perry, and here we are with the first video for lesson for Unit 3. So let's go ahead and get started. So we're going to start with a little bit of a hypothetical scenario. Let's say that Mr. Perry disappeared, and the authorities went to Mr. Perry's house, and were looking for some clues. And let's say that they found this ID. And they're like, okay, well, nothing suspicious here. It's a Michigan ID. It's got his birthday, got his name, got his address. But then let's say they kept looking through the house and they found another ID. And this was what it was. Same birthday, same address, different name. This time going by the name Gumster Boboham. And then they found another ID. This time it was this one here. Same birthday, same address, going by a different name, Woody Woofsniff this time. And then they found even another one. They yet another ID, same birthday, same address, this time going by the name Hick Wax Pants a Lot. So the question here is, what conclusions might you draw from these ID cards? Why would somebody have a bunch of different ID cards, same birthday, same address, different names? What would that mean? Well, clearly one conclusion that we can draw is that apparently Mr. Perry was going by what we might call aliases. So aliases are when people use different names even though they live at the same address. So if you've got the same address but you're going by a bunch of different names, then all of those different names are called aliases. And believe it or not, this whole concept of residing at the same address but having a different name relates to what we're going to get into today with the very first lesson of Unit 3, Lesson 1, which is all about Boolean expressions. Let's go ahead and hop in here. So when we talk about something being Boolean, whether it's a Boolean variable or whether it's a Boolean expression, what that means is it can only have true or false values. So down here we have a Boolean variable called is snowing, and it's being assigned the value of false. So pretty straightforward. But down here it says if is snowing equals true, this is what's called a Boolean expression, which means that this expression is going to evaluate to either true or false. Well, the Boolean variable is false, so does false equal true? That would be false. So this whole thing would evaluate to false. So Boolean variables are just your variables. Boolean expressions are something like this, where you've got a value being compared to another value, and again, the entire expression is going to evaluate to either true or false. By the way, you can also do it like this. This is a variation of the Java syntax. If you say if is snowing, this is the same thing as testing whether or not if is snowing is equal to true. So you'll see it both ways sometimes when you're programming in Java. Most new programmers will do it this way because this is, we might not know all of the shortcuts. But this technically is a shortcut. You can just say if and then in parentheses is snowing. And that's going to test whether or not is snowing is equal to true. All right, so how would we test primitive data types for equality? If we wanted to create some Boolean expressions and we are testing for primitive data types, whether or not they are equal to one another, we're basically saying whether or not they have the same value. So if we wanted to see whether or not a bunch of doubles are equivalent to one another or whether or not they have the same value, we could do something like this. We could put them in print statements and we could say print Monday snowfall equals Tuesday snowfall. What that's going to do is it's going to see whether or not this value, 0.0, is the same as 0.5. Obviously it's not. So we would expect that to print false. We could also print Monday snowfall equals Wednesday snowfall. We've now created a Boolean expression to see whether or not this is the same as this. And of course it is, so we would expect this one to evaluate to true, and so true should print in that one. And then if we're printing whether or not Friday snowfall is the same as Friday snowfall, obviously 2.0 is the same as 2.0, so this would evaluate to true. So we would get false, true, true. That's what would print in these print statements. We could also do this same thing with integers if we wanted to. int player 1 score is set to this, player 2 score set to that, player 3 score set to that, and then high score set to that. So if we put in print statements, player 1 score equals player 2 score, this is a Boolean expression checking whether or not this is the same as that. Obviously, as not, we would expect that to be false. And then if we did player 2 score equals player 3 score, that's testing whether or not these two values are the same, which obviously they are, so that's going to evaluate to true. And then player 1 score is not the same as the high score, so this would print false, true, false. So Boolean expressions are pretty straightforward when you're testing for primitive data types. You just use equals to see whether or not they are the same. But things are different when we're talking about reference data types. And what you have to remember is that reference data types are pointers or references to addresses in memory. So if you create a pet object, if I did pet Baxter equals new pet, and then passed in Baxter and 7 as the name and the age, what this actually does is the name Baxter, the variable name Baxter, is a pointer to an address in memory. Now, on the next line of code, when I instantiate another object of the pet class, this time naming it Snowball, that variable name is now a pointer to a different address in memory. And so now, if I did pet my pal equals Snowball, what this line of code does is this creates an alias for Snowball. My pal, the variable name my pal, is going to point to this same address in memory. And so what that means is we just created aliases in Java, and that's because Snowball and my pal are two different variable names, but they both point to the same address in memory. So when you see program code like this, when you see objects of a class being instantiated, and then you have another object of a class, and it's set to be equal to one of those previous objects, you've just created an alias for those objects. And we would say, therefore, my pal is equal to Snowball because they both refer to the same address in Java memory. So that's an important distinction to keep in mind. If I had those 3 lines of code, and then if I printed is Baxter equal to Snowball, that's going to print false because they are not aliases of one another. And then if I printed Snowball equals my pal, well, these are aliases of one another, so that's going to print true. But then if I printed Baxter equals my pal, that would be false because, again, Baxter is not an alias of my pal. So if we're talking about reference data types, if we use equals, what we're actually testing is whether or not they are aliases of one another. So we can also create Boolean expressions using the relational operators. So if we're using primitive data types, ints and doubles, we can see whether or not an int or a double is less than another int or double, whether or not something is greater than another value. We can test whether or not something is less than or equal to, whether or not something is greater than or equal to, and then again, equals is what we use when we're testing whether or not they have the same value. And then we can also use exclamation point equals, which means not equal to or does not equal. Now, we do not use equals for strings, remember. The string class has its own separate method called the dot equals method. And so strings do not apply here. But primitive data types, we can test them this way. And if we're testing reference data types, we're testing whether or not they are aliases of one another, and we would only use equals or not equals in that case. These ones up here would not be appropriate for reference data types. Now we can also add the not sign in front of just about anything. So not less than is the same thing as greater than or equal to. So not less than is equivalent to greater than or equal to. Not greater than is the same thing as less than or equal to. Not less than or equal to is the same thing as greater than. And then not greater than or equal to is the same thing as less than. So it's a good idea to put these on your radar. Just remembering that when you have the not sign in something in front of something, it always has an equivalent relational operator. So these are good to put on your radars. You will definitely have questions that involve equivalent relational operators. All right, so let's look at some sample problems here now. I'm going to encourage you to pause the video here and go ahead and evaluate bool 1 all the way down to bool 5. So these are all Boolean variables, and they are being assigned a specific value. And that value is going to be the result of these Boolean, relational expressions over here. So you've got to go through and just kind of figure out, are these going to evaluate to true or are these going to evaluate to false? So go ahead and pause that video and work your way through them, and when you're ready to check, go ahead and keep going. I'm going to assume you paused the video at this point, so let's go ahead and look at our solutions. So the first one, it is true that it's false that 33 is greater than 40, so this is false. 8 is less than 10, so that's true. So does false equal true? It does not, so the entire thing evaluates to false. Down here, it is false that 3 is not equal to 3, so this would be false. Over here, 4 is less than 3, so this would be false. So is false equal to false? Yes, it is. So this one evaluates to true, and there you go. Let's see, over here, 5 divided by 2 is just going to be 2 because this is all integers. So 2 plus 2 is 4, and does that equal 8 divided by 2? Yes, it does. So this is going to evaluate to true. And then 100 mod 10 is 0, and 0 definitely is less than 10, so that's true. So you've got, is true equal to true? Yes, it is, so the entire thing evaluates to true. Down here, let's see, we've got 100 minus 50 gets you to 50. Is 50 greater than 49? Yes, it is, so this is true. And let's see, 3 times 3 is 9. Is 9 greater than 5? Yes, it is, so that's true. So let's see, is 50 greater than 49? That is true. And then is 9 greater than 5? That is also true. So wait a second, what's going on here with Boolean number 4? It says it evaluates to false. Am I missing something here? 100 minus 50 is 50. 50 is greater than, 7 times 9 is 63. I'm doing the wrong mental math here. All right, so that's going to be false is equal to true, so that's why it evaluates to false. Okay, and then finally down here, 9 times 9 is 81. Add 3, you get 4. Is 84 less than 50? No, it's not. That's false. And then over here, you've got 1 plus 5 is equal to 6. 6 is not equal to 3, so that's false. So you've got, does true equal false? No, it doesn't. So that ends up being false. All right, well, let's go ahead and keep going. Hopefully that's making a little bit of sense to you guys. And if not, hopefully just with some repeated practice, this whole evaluation process gets a little bit easier. I do want to point out there are some other really useful Boolean expressions that are worth just kind of remembering. If you want to test if a number is positive, obviously you're just checking, is the number greater than 0? If it's negative, it would be less than 0. But one easy way to test if a number is even is by seeing whether the number mod 2 is equal to 0. So any number modded by 2 equal to 0 means it's an even number. And if any number modded by 2, if it's 1, then it's going to be odd. So you could test that, is the number modded by 2 greater than 0? Or you could just say, is the number modded by 2 equal 1? That would also test whether or not it's odd. And then if you want to test whether or not is a multiple of another number, you can see whether or not that number modded by the other number is 0. So if you wanted to see whether or not a number was a multiple of x, you could say, well, if the number modded by x is equal to 0, then it must be a multiple. So those are just some easy-ish Boolean expressions to remember. And let's see, you can use mod in a couple of different ways in some Boolean expressions here. So, you know, again, if num mod 2 is equal to 0, that means it must be an even number. You could do if num mod 2 is not equal to 0, that means it's got to be an odd number. And then down here, if num1 mod 2, if num1 modded by num2 is equal to 0, then again, you would say num1 is a multiple of num2. And then remember that mod operator is also useful in other mathematical expressions. So for something like this one right here, if you had the total number of minutes, but you wanted to figure out how many hours it was and then how many minutes there were, if you wanted to convert a total number of minutes to number of hours and then number of minutes, what you would do is you would divide this by the number 60, and that would give you the number of hours. And then if you take your number and mod it by 60, that will return the remainder after it's divided by 60. So that would tell you how many minutes. So these are just some other ways to, you know, just kind of keep in mind that, you know, taking a number, dividing it by something, and then modding it by something is something that you see a lot. We saw this in our earlier lesson when we were taking a number and trying to figure out what is the ones digit, and then, you know, breaking the number up by the tens and then the hundreds column. All right, well, with that, I believe we've come to the end of our lesson here, guys. So we'll do our quick lesson review. Remember that primitive values and reference values can be compared using relational operators, such as equals equals and not equals in Java. Primitive values can be tested for equivalence using equals equals, whereas reference data types can be tested whether or not they are aliases of one another using equals equals. And remember, they are aliases if they reside at the same address in memory but have different names. Arithmetic expression values can be compared using relational operators. So again, you can do some math on one side and then see if it's greater than or equal to, and then do some math on the other side. And an expression involving relational operators always evaluates to a Boolean value of true or false. So you always have to work through the math and then look at the numbers and see whether or not they are true or they are false. All right, guys, that's it for today. I will see you in class.